In this video, we're going to go over the External Devices tab of the system hardware. This tab is used to configure devices such as a digital I/O, RS-232, GPIB, foot switch, or a buzzer. This table contains two discrete sections, digital I/O and interface. Adjustments made in one of these will not affect the other. Let's look at the digital I/O section first. By default, it's disabled. To turn it on, all we do is click Enable. Now the digital I/O section is no longer grayed out and is active. Once the digital I/O section is enabled, we'll still need to start adding ports. This is done by using the right-click option. So anywhere in this table, I'll right-click and select Add Port. You can see now that automatically some information is filled out. Port number is auto-incremented each time you add a port, so here it starts off as 1. This can't be edited. Port width is the number of bits specified to a port. Even if you won't be using all of the bits, you should still fill in the maximum number. I/O allows you to select the port as either an input or an output. We also have the right-click function of Duplicate Port. This will copy the selected port number and carry over the port width and input-output selection. Now let's move to the interface section. Similar to the Digital I/O tab, we'll need to right-click to add an interface. Once again, some information will automatically fill out in the table. Interface number is auto-incrementing by SoundCheck, and it's what SoundCheck references when it talks to the interface. Each added interface will ascend one in order. Type is where you select what type of device you are using. This is a drop-down menu. There's IEEE 488, which is GPIB, RS-232, foot switch, and buzzer. RS-232, foot switch, and buzzer will need all columns filled out. However, you'll notice when I switch to GPIB, only COM port/device ID remains active. Everything else is not applicable. The right-click duplicate and delete options are the same here as they were in the digital I/O section. COM port is the communication port number as defined by the operating system. Device ID is specific to National Instruments devices. Baud rate is the transfer rate speed of the communication port in bits per second. Data bits will specify the data bits for this port. Parity will give you a drop-down option, where you can select none, odd, even, mark, or space. Stop bits will allow you to select 1, 1.5, or 2. And flow control is X on/X off, hardware, or none. These settings are usually device-specific, and you'll need to consult your hardware manual to see what is appropriate. So how do we know which values to fill into these columns? Currently in my computer, I have a National Instruments 6503 Digital I/O, a National Instruments GPIB card, a USB to RS-232 connector, and a PCIe to RS-232 connector. The first spot we'll need to look is the Device Manager. So I'll click on Start, right-click on my computer, and select Manage. On this next screen, we'll click on Device Manager. This shows a list of all devices recognized by your computer. First thing we'll look at is the RS-232 devices. An important note on this. Even though one of my RS-232 devices is connected to my computer via USB and the other via PCIe, they will still show up under the Ports section. When I expand the ports, Communications Port 1, or COM1, is my PCI to RS-232 connector. The prolific USB to serial COM port is on COM3. I'll double-click on COM port 1 and the properties will open. The Port Settings tab is what we're looking for here. Every column that's available in SoundCheck is replicated here, so all we have to do is copy this information into our hardware table. If we go back to Device Manager, we can compare the two and see they're now exactly the same. Next, we'll look at COM port 3. The settings are exactly the same between the two, so we can duplicate what we just entered and only change the COM port to 3. The GPIB device I'm using is made by National Instruments. We can see it here under the National Instruments GPIB interface, but this actually isn't where we get the settings. This is the same case for the digital I/O. We'll have to use a third-party program to look at the settings. That program is National Instruments Measurement and Automation Explorer. It's available free on their website. Once this program launches, we'll want to look at devices and interfaces. If we expand here, you can see a list of everything on the computer. This will also show the RS-232 devices and show the port settings. Here's the digital I/O I'm using, the PCI 6503. We can see it's labeled as Device 1. I'll go back over to SoundCheck and change the device here to 1. Now that the device number is plugged in, I'm actually going to look into the hardware manual for some of the other settings. Reading this section, we can see the 6503 contains one parallel port interface with 24 bits of I/O with 3 8-bit ports. Each of these can be configured as either input or output, so I can choose whatever I want here. But the important thing is I'll need 3 ports with 8-bit width. I'm just going to change these 3 to inputs for now, but according to this manual, we could have selected either. So now my 6503 is ready to use. The last thing we'll need to look at is the GPIB. Here it's labeled as PCI GPIB GPIB 0. Now we'll go to SoundCheck, delete one of the extra interfaces I had from earlier, and select the device ID of 0. There's no other settings needed for GPIB, so now all of our external hardware is ready to go. I'd like to quickly look at how to communicate with these devices in SoundCheck. I have an interface message step out right now. We can see to the left there's a digital I/O or interface option, which are the 2 that we'll be interested in. This number dropdown, 1, 2, and 3, corresponds to the interface number in the hardware table. So if you recall, 1 was our GPIB, and 2 and 3 were the RS-232s. Once each of them is selected, the other options in the step will change. Now if I click Digital I/O, you can see there's different port dropdowns. I configured it for 3 ports, which are all input, so whichever one of these I choose, there's 8-bit ports that are all set to input. If I write a sequence, I can simply insert a message step that will reference my different interfaces.